My name is Miel. I'm the data architect at Meemoo, and I'm going to tell you a bit about the transition in metadata infrastructure that we're going through right now. So first I'm going to talk a bit about what Meemoo does and who we are doing it for, what the drivers were for getting or transitioning our metadata approach. I'm going to dive into how a knowledge graph infrastructure might or looks like, and talk about a bit about how we did the data modeling, and close with some lessons learned and some ways forward. So what do we do at Meemoo? We are an organization that supports media, governance, and cultural organizations in preserving their digital heritage in an accessible and usable way, which is mainly audiovisual. Some services that we provide: we digitize content, we archive it and preserve it for the long term. Like we make it accessible and very usable, but we also do some knowledge sharing, know-how sharing on digital heritage in general, but also in digital archiving processes and operations. We do this for about 172 partners, which provide us with content, so that's why we call them content partners, and they're spread around the Flemish and Brussels region in Belgium. And they are spread out over a lot of sectors. So we have performing arts, we have museums, we have the broadcasters, both national and regional, and then some other heritage institutes. And yeah, obviously they all have a different view on what metadata is or supposed to be, or I wouldn't be here. We run some platforms, some interaction platforms, where we make the content accessible. So this is the heterogeneous.be, which is for the general public, some publicly accessible metadata browsing. This is the archive for education, which is targeted at teachers who use our archive materials in classrooms. And we also enable partners to use whatever's in the archive and that they of course own to put it on their own website by connecting through our APIs and so forth. In summary, we have about 6.5 million objects, which amounts to 23 petabytes, more or less. We have digitized about 500,000 audiovisual carriers by now, and we have about 170,000 users on the Archive for Education platform, which is also our most used dissemination platform. And we use a lot of metadata. We have metadata in all our processes. Actually, it's extremely important for making sure that you can search and explore the archive, both for our users and for us as well, to make sure that we can actually preserve and digitize. We have to know when formats will be deprecated. We have to know what the characteristics are of certain audiovisual carriers. And when things go wrong and things break, we have to use metadata to find out why it happened and where the things are that we need to fix. So lots of diagnostics and operations. So next, so what were the drivers for a new metadata roadmap? So the infrastructure was looking more or less like this. We had a media asset management system in the middle, where we were building a lot of APIs on top, so our platforms could access the metadata and the media that our content partners were putting in there. And then we also had some other independent, let's say, systems that also provide data that we would also integrate in there. And so all these systems have they kind of use different metadata models. All our partners use different metadata models. So we were not fully realizing it, but we were doing a lot of metadata integration without really acknowledging the fact that we were doing this or giving it a lot of attention. And so this worked and still works, but we saw some symptoms popping up, like the fact that our metadata practice were showing signs of decay and was reaching its limits. Basically, we were growing in volume and variety, and there were just too many domains with specific needs, and we could not fit all these needs and these domains into this model. Also because the data model was a bit too much one size fits all, and simply could not really deal with the heterogeneity of the data. Another thing was also that the metadata model and all the schema that we had was really underspecified, so we did not really have the practice of making definitions, labeling things, getting consensus about labels, and document them in a proper way. And the fact that we did not have this shared vocabulary about what the concepts are, what their properties were, what the properties mean, also led to some miscommunication. And we also still have plans, so we have a lot of big, ambitious plans with our archive. We still get a lot of new analog carriers that come in, or types of carriers as well. We accept new types of media, so we recently started archiving 3D objects, 3D scans of museum objects, or glass plate photography scans. There's also a catch-up process by our content partners. They're trying to create more metadata and annotate their own material, and of course this data has to come back to us. But at the same time, we're running a lot of AI tracks at this point, speech-to-text, face recognition, and named entity recognitions, which of course also produces a lot of new metadata, but also new types of metadata. For example, coordinates of a face in a picture, something that we did not really have before. And there is also this desire to connect the metadata more to external authorities, vocabularies, thesauri, taxonomies like AAT or GTAA, and of course add more useful services on top of the archive. One concrete example of that is having IIIF access to images. This led to a 5-horizon roadmap, basically, where we first look into, okay, what is the state of our metadata, what's the quality, how can we assess or measure the quality of the data. Second, looking back or revising the data models, trying to capture all these definitions, these semantics of what the data means. Third is building a knowledge graph to tackle the data integration problem. I will come back to that, of course. Fourth was, okay, once everything is in a knowledge graph, or once the knowledge graph is there, how do we do the ins and outs? And fifth is then really starting to collaborate on the data level, connecting to other partners and basically doing linked data. So how does the knowledge graph infrastructure look like? So this is what we had, and so the way we were handling things was we had all these data sources at the bottom. They would provide metadata that would go almost directly into an API for one or more platforms, usually just one platform. So they had these custom integrations and implementations, and they were not very reusable. So we were approaching things in a very siloed fashion. And so we were really thinking about, okay, we need this layer that would make access to the metadata universal, so blur the lines between these input sources, these data sources, so you don't have to think about, okay, where is this type of data, where can I find it? But also be application independent in the sense that it is just not like the application has specific needs, and then tailoring your metadata to this application, it won't work for another application, so it would hinder the reusability. So in the end, this layer then became our knowledge graph. So why a knowledge graph? Why a graph? A knowledge graph is basically representing the archive metadata as nodes connected by edges. And this is also the way that you query the metadata. So for example, if we have a news item which is maintained by our VRT, which is an organization, which is our public broadcaster, but the same news item is also tagged as being suitable for a second grade English class, for example. So we have some educational metadata combined with an object, combined with an organization metadata. Or, for example, linking to Wikidata or any other external data source to say, okay, this person is actually involved in this news item. And so this is really an intuitive way of navigating through metadata. It supports discovering what is in the data while you are navigating it, really traversing to the graph. So it's a very flexible data structure, and this makes this is really a strong point because you don't hit these walls, because you can just keep scaling the graph and scaling the graph. So that's one good thing. But if you wanted your metadata to remain usable, you have to still invest in what are the semantics of the graph, what is the schema, and constraints are all still very essential to, in the end, be able to use it. And so it's not only about representing and storing. I mean, the end goal is really about making metadata as accessible as possible. And do this in an application-independent way, in the sense that if we look for something, we usually start with an identifier, and then we go like, okay, I have to search through 5 different systems. Where is this identifier located? Who knows something about this? In which field, in which system do I have to look for this identifier? And so the goal is really about, you take this identifier, you put it in a browser, and it just gives you everything we know about this thing, or everything Meemoo knows about this thing, which would already help external people, but definitely also our own personnel. And of course, this relates to having persistent identifiers, persistent URIs, and also a bit linked data, of course. And so what does this infrastructure do? So we basically start from having all these systems who are very tailored to a specific need. So they do one thing and they do it really well, or at least they are supposed to do it well. So they are single purpose, and we brought the spectrum of the metadata and make it as general and as generic as possible, so we can go all sorts of ways. And then we reverse this pyramid where we go from general purpose back to single purpose. So at the top we have our users. So there we have our platforms that do something really well. They really serve, or they should serve, the end user. And what we get is in the middle, because we have this very general purpose layer, which is very flexible, it's a lot less costly to create targeted APIs that target one or more applications. So they are multi-purpose, but they can already simplify a lot of the complexity that is in the data, like omit irrelevant domains, or simplify some of the constructs that make more sense in an API. And so we have this 3-layer dissemination infrastructure, and they all have different needs. So the knowledge graph is really thinks about what are the needs of the data. Being able to scale, being able to put data in there without hitting a wall or things that do not fit. Flexibility, semantics, what do things mean, providing context, putting relationships between things. And then on top of that, you have this API layer, which really thinks about what does the application need, and that's more about being developer friendly, being interoperable, providing the data in a format and with a protocol that developers can use, and of course do this in a performant way, so it has to be fast enough. And then at the top you have these platforms, and there the focus is on the user. So how do we present things in a focused way, simple, important that on the data level, once you're in the platform, there are no surprises. No data that you did not expect or data that is missing that was supposed to be there. So how do we model this? Or are we modeling this? So we have this, we adopted this cyclic methodology where we first go through this knowledge capture phase. We organize business working groups with our staff or with partners that produce these business questions. So the questions that try to capture what are we trying to do with the data. We analyze the existing data, the existing schema, what did we have before, standards that are important, and have interviews with people to see, okay, what are the pain points, what are your wishes, and so on. This leads to a knowledge inventory. And there we go, from there we go to the knowledge implementation phase, where we start to first make a nice drawing on how we think the domain looks like. We make a diagram, we formalize it in some kind of schema language, and create documentation so everybody knows how the data model looks like. And so the output of the knowledge implementation phase is actual specification, which is basically a vocabulary or a schema or a thesauri or a combination of these things depending on what the domain requires. And then these specifications we evaluate using the business questions from the first phase to see, do we answer these questions? If not, we go through the cycle once again. We identified some domains where we apply this. So we have, of course, our object structure and preservation, which is really the core model. And then we have, which is based on premise OWL. And then we have some satellite domains that we identified that we have worked on or still have to work on. So we have organization metadata using the organization ontology of W3C. We have events and provenance, where did metadata or objects come from. So this uses prof and premise OWL. And then we have a general discovery model, which is very high level, web search, schema.org and Dublin core. And then things we are still looking into is digital media, technical aspects of different contents, more specific domain discovery, so for people in a specific sector, how they want to approach the archive, and usage rights, which is also looking in the direction of ODRL. And then in addition, there are also a lot of thesauri that we publish as SCOS. So we did things on the education system. We have a list of organization type, file formats, event types, and so on. And also there we are still working on licenses, roles of authors and AV carriers. And we try to reuse as much standards or lists of authorities as possible. So an example of a thesaurus here, they are all published online. We also have our data models published for who's interested. The links are in the slides. And how does this look like then? So we have our intellectual entity, which is where the metadata about the content lives. So for example, a specific film that is described. And then we have a bunch of representations. So we have digital representations. which can, for example, so those are actually the reproductions, for example, in different resolutions. So the archive master is one of those. And the physical representation, which can be a carrier, or if it's a museum object, it can be the object itself. And then these representations, or at least the digital representations, contain one or more files depending on what's necessary, and then the technical metadata then is described there, so like the file format and the fixity and so on. So an example of a popular film, so we have Titanic, that then, for example, would have a high resolution copy, a mezzanine copy, and a low resolution copy. And these then include a DPX, a MOV file, or an MP4 file. And this would then be stored originally on the Titanic film reel. So, what can we conclude? One of the things that we found important during this process was really composing a good data tool chain. There's, coming from a metadata management perspective, it's not always obvious, but in the data science domain, they actually invest a lot of tooling to prepare data, to do all sorts of analytics or machine learning. And there's a lot of things that you can learn there, and so we took a lot of inspiration from this domain. So first we bought a graph storage and RDF mapping solutions, which ended up being TriplyDB. We also adopted a lot of open source tooling. We do workflow automation in a system called Prefect. We have a GraphQL over Sparkle framework that allows us to build GraphQL APIs quite rapidly. We are looking for a SCOS editing tool. We also already think about a tool called Atramazis, but we're still looking. And we also built some custom tooling, for example, if we have a formal data model to generate documentation that is human readable. Another thing I want to note is that it's important to invest in good data management. It takes effort, it takes time, it takes budget, it takes people that know about how to handle data, but it's really worth it. Data modeling is a bit of a lost art, especially we had this big data revolution and then people started to give up on the schema, but it's still really important if you want to make your data usable and to know what it actually means and what data matters. Try new data technologies. Metadata, it really feels and navigates and looks like a graph, so why not use graph technology? And the RDF ecosystem, in fact, is quite okay. If you come from the AV archiving perspective, there's a lot of things that are already there that you just can combine to give you a head start. So where are we now and where are we going? So what have we been doing? We have really made an inventory on the different data that we have and domains that we're active in, the knowledge domains. How do they look like? What do they do? What do they need? Mostly doing data modeling, creating and formalizing these models, and setting up our RDF knowledge graph platform. What are we currently working on? Mostly building ETLs to map our existing source data to the new data models. And then, of course, to have these ETLs, you also have to think about the conversion rules and how to interpret the source data. And we're also still developing or improving our GraphQL framework to build APIs. And that concludes my talk. Thank you.